Okay, welcome back. Those of you online, are you able to hear me?
Yes, sir.
Thank you for the confirmation. It's 11:15 a.m. I said I'll get started at 11:15 and I am going to start at 11:15. So welcome back. What I wanted to do over the next few slides, I believe I have about 12-13 slides to go, is try to make one more connection. We talked about engineering, enforcement, identifying repeat violators, but what do we need to do to bring about a behavioral change? So this is where the examples I used about the lawyers and the judges, and building upon this particular example, bad example of bad behavior that I showed you right before we went for the break, where there was one driver who had multiple infractions but who got away each time without any serious ramification, except one of those times the person paid a monetary fine and then got away. So the concerns that we have in the state include revealed many gaps between communications or data sharing between agencies. Different police agencies did not talk to each other or did not communicate data, exchange data with each other. Then even when a person got this challan, this violation notice, the person was able to go to a court and tell the judge, I won't repeat the violation or whatever that, and got a monetary penalty, but that was not, but continued to repeat it. The moral of that is maybe the monetary penalty was not substantial enough to make a difference in the person's behavior. So the picture in the left is from that particular crash. That was the red vehicle, that was red color, is driven by the motorist. The second one is in a court, and there was very little tracking of this individual's record. And like in India, in the US, you get a driver's license from each state. If you live in Assam and you have your vehicle here, you register it here, you get your driver's license here. Doesn't mean you cannot operate it in other states, right? But when somebody moves from one state to another, they're typically there, you're required to get a new driver's license that is from that particular state. But there's no communication from the previous state saying that, hey, this person had a good record, a decent record, not too bad record, or the person had lots of violations. So it's just, oh, you go, you transfer your license, that is about it. Speak up, please, use a microphone.
So I'm Ishita Pragya. Sir, I have a question. If somebody is like going for a vacation and using some car, then what he will do for the license? He'll get new license in
No,
other.
when you are renting a car in the United States, you are allowed to use your driver's license across the country. If you're just going for a short, but if you move your residence, maybe you are living in Assam and you move to West Bengal for studies or for work, then if you own a motor vehicle, if it was registered in Assam, you have to now register it in West Bengal. Except in the US, there is an exemption for education. If you're just moving to study, you can keep your original state's driver's license and your original state's motor vehicle registration. But if you're moving there for work, you have to get these. There's a limit, I believe it is 90 days, within 90 days of relocating. Did I answer your question?
Sir.
Okay, thank you. So here, this is something to go back to what I mentioned yesterday. In Nevada, this is going back to 2022 data. There were 383 fatal crashes, which resulted in 416 fatalities. So approximately 1.1 persons killed per crash on average. There are crashes where you have more than 2 people killed. But there were 48, nearly 50,000 what we call traffic contacts. Police interacted with motorists because of crashes, not just challan, because there were crashes. So keep this number in mind, 400 average of these two, 400 fatal crashes or fatalities, order of magnitude, about 40,000 or 50,000 crashes or collisions, about 400,000 challans, citations. So do you see that? So for every fatal crash, you had many more, I mean for every fatality, you had, for 400 you had 40,000, right? So that's a factor of 100, 40,000 crashes. So for every 40,000 crashes, you likely will have one fatal crash. That's another way to look at it. But for the 40,000 crashes, we had 400,000 challans. That is, for every 10 challans that are issued, there was one crash. And the vast majority of these crashes were minor property damage. We'll see that in other data. The point is, if we are only going to go after those who have or who are involved in a fatal crash, we are missing opportunities to improve safety. Let's look at the data we have from the 400,000, 4 lakh citations. And for every citation, there is probably at least 100 or 1,000 near misses, somebody braking abruptly or swerving abruptly to avoid a crash. So when we look at new technologies, we'll see how we can get that data also. So now you're looking at 4 million such records. So even if it is a factor of 10, maybe more. Could it be 40 million? So then if we can get to those risky behaviors that early and come up with interventions, if it is an engineering problem, we need to fix that. But if this is a place where people are just speeding all the time, maybe we want more law enforcement, and we can try to guess who is traveling in that corridor, better education. So this is another way of looking at it. At the bottom row here, what I have is, for every fatal crash, there were 128 police interactions in crash reports. Or if I look at fatalities, because you have more fatalities, that is 117. For a measure of exposure, for one fatality, you had 1.5 million vehicle miles of travel. That's a lot of travel before we have fatality, which is good. But the vision is zero. We want to get to 0 fatalities or as close to 0 fatalities. And if I look at it per population, it is 13.09, which is high compared to the developed nations. Remember, we said 2.8, 3, 4, something in that order of magnitude for Western Europe, so on, and it was 28 for Africa and the less developed nations, Southeast Asia. So Nevada is not great at 13 per capita, but per capita is not necessarily a good indicator, because we have a lot of interstate travel through Nevada. So it's not the people who are living in Nevada who are getting involved in these crashes. A lot of people are people who are just driving through, who are not residents. And we'll look at that later also, is how do you account for safety outcomes, measures of exposure. So the next couple of slides are very busy. The first slide is all crashes. Afterwards, I will just go to the K and A, killed and serious injury crashes. On this, I have the years from 2015 on the x-axis, 2015 to 2022 on the x-axis, and for each year we have one column for rural, one column for urban. Y-axis is a total of 100%. It's not the count, it is 100%. So if I were to look at it, the solid red bars, I'll go to the first bar in each, are the property damage only crashes. So in rural areas, you can see that it ranges from about 65% to 70%, coming down to about 60 to 63%. So it's somewhere between, let's say, 65%. That's property damage. However, in urban areas is the second set of bars. It's 50%, 54%, 56%, 50, 50. So it's closer to 50%. So in urban areas, we have a lower proportion of crashes that lead to property damage. the next set of bar. So the numbers here within each bar are the actual counts, the number. So in rural areas it is 2,163, 2,300, 2,500, and coming down to 1,200 here. So the numbers have declined in terms of actual number. But in urban areas it's about 10 times as many. Instead of 2,000 it is 19,000, 18,000. Instead of 1,300 it is 16,000. So it's a factor of 10. If I were to look at the next is the C-type crashes. So if I look at O plus C, it is about 80% across the board for rural. It drops here. Urban areas, what you see is a higher proportion of minor injury crashes compared to rural area. Then if I go to B-type crashes, the percentages are somewhat similar but not quite. About 12% in rural areas and about 14-15% in urban areas. So that's not as dramatically different as we saw in other places. But the total numbers at the top of this chart are in each year how many crashes did we have. So you're looking at between 35,000 and a few years we had 48, 49,000, came down to 35,000 crashes in 2022. But on the next chart, I didn't talk about K&A on the previous one. I just wanted to zoom in here. For the K&A, something we saw the first part of this morning's lecture. In rural areas, you see the blue type is A-type, blue bars are A-type injury, red are K-type. So percentage wise, it is about 70% of the K&A, between 65 and 75% of K&A crashes are A-type crashes in rural areas. However, if I go to urban areas, that is much closer to 85%, 80 to 85%, which means the flip side is in rural areas you have a higher proportion, 25 to 30% are fatal crashes when I look at just K&A crashes, which was one of the earlier slides that I showed you. Any questions, comments? Now how does this relate to the court system? So I'm going outside of engineering. So this is the map of the state of Nevada. Map of the state of Nevada on the right side. Las Vegas is located here. Reno, Carson City are located here. This distance north-south is about 700 kilometers. I'm trying to convert from miles to east-west is about 500 kilometers roughly. Don't hold me to that order of magnitude. The whole state's population, okay, don't ask Google, don't search online. 30 seconds. What is the population of the state of Nevada? Based on all the data that you've seen, I've given you per capita crashes, so on and so forth. I've given you crashes. I'll give you 30 seconds to come up with an estimate of the population of the state of Nevada. Please don't look up any references. Talk to your neighbors. 30 seconds from now. Okay, time. Anybody in class in the room here want to venture a guess? What is the population of the state of Nevada? Raise your hand and I'll call on you. 4 million? Anybody online? Ashwini? Speak up. I can't hear you, Ashwini. You're muted.
I think about 1 million.
1 million. Okay. Ishita, you said? 30 lakh. That is 3 million. Anybody else? What makes you give me the numbers as 3 million, 5 million, 1 million and not 30 million? You're looking at these numbers here. Smart. Yeah, it's about 3.2 million. That's smaller than most small size cities in, yeah. Look at the area. And of that, Las Vegas accounts for 2.3 million. Reno, Carson City accounts for about 500,000. You can see that in the populations, 2.3 million. This county has about 60,000. So it's very sparsely populated. So what I meant here, we have some major roadways that serve interstate. That's beyond the point. The reason I wanted to bring this up is we have 17 counties or districts in the state of Nevada, and that is divided into, we have multiple types of courts in Nevada. We have the Supreme Court for the state, we have district courts that are more at the district level, and then we have municipal courts. The municipal courts don't talk to each other, they don't communicate the case data. The municipal courts don't talk to the district courts, the district courts don't talk to each other. So there is a lot of disconnect, just as the example I showed you previously of that one driver who killed 9 people, including the driver. So if I looked at this, of the 11 how the cases are, and I will analyze this. So the first column is the district. There are 11 districts. Which are the county? County is the district, name of the district. How many non-traffic cases they had versus how many traffic cases. So we don't have any courts that focus only on traffic cases. I believe that's similar here in India. Do you have any courts that are just for traffic violations? Occasionally I think you can see, oh, there's a day when all the challans will be handled, so on. But other than that, I don't know whether that's a fact, that there are some courts that will only handle traffic cases. So if I go to the next slide, looking at it per capita, per 100,000 people or per person, what do these numbers? So on the y-axis it is percentage, x-axis are the 11 districts, and the ratio that I have is what is the average for the whole state of Nevada. And if a particular court has a number that is 100%, that means its ratio is the same as the state average. If the number is greater than 100%, it means its load is greater than the state average. So we see there are two counties here, 2 districts where you have 440%, 390%, and 200%, nearly 200% of the state average, whereas there are several others that are below the state average. So that means there is an imbalance in the caseload. Is that why some of the traffic violations are not being adjudicated, or the judges don't have enough time, there's too much workload, just chalado, chalado, chalado? And the individual bars here are non-traffic cases is the light blue, traffic cases is the pink, that's where I have highlighted. The traffic cases are very high, and the green is the average of traffic plus non-traffic cases. And we are using this to work with the judges, to work with the state legislature, to say, hey, here are certain districts that have a very high load. Can you allocate more resources? Somebody said online earlier today, allocate more funding for appropriate strategies. Here it is not a countermeasure or intervention per se, it is to adjudicate the cases. So the concerns, we have talked about this. We have repeat offenders, disconnects between courts and the various levels of courts and the attorneys. I said we have no special courts for traffic citations, and there is a public apathy. We believe there is public apathy. There's indifference. Oh, so what? Oh, I got a ticket for traveling 10 miles an hour over the posted speed limit. I paid the fine, or I talked to a lawyer, the lawyer got it reduced to a parking violation. If, once again, now I'm talking about my personal values and philosophy. If an individual is willing to violate traffic laws, is that an indicator of the likelihood that this person will violate other laws, other norms, cut corners? Why then, as a society, we are not asking better of ourselves and our neighbors? Many parts of the world, in Europe, in Australia, New Zealand, it is stigma, public stigma, if for you to have been pulled up in traffic court for driving under the influence or over speeding, so on and so forth. Why are we so blasé about, hey, chalta, it's okay. Only when there is a very serious injury or a fatality do people take it serious. Oh, it's not me. Just like the crashes we talked about, 40, 43, 44,000, like a jetliner crashing versus crashes, 100 crashes occurring across the state. Oh, it's not in my neighborhood. Usually if there's a crash or fatality somewhere in your neighborhood, you will see hundreds of people standing there and looking at what happened. But then after 5 minutes, 10 minutes, 1 hour, everybody disperses. But if it hits your family or friend, then why this public apathy? So that's my personal spiel. And linking driver's licenses with motor vehicle registration with insurance. We need to do a better job of tying these three together. So if there are issues with one, chances are there are issues with the other. And how can we tie these three together along with challans and other violations to improve road safety? So the data, we'll get into that, transition into that in the next lecture to lead into that. We can look at legacy. What I say legacy is what we have had for years and years, and recent and emerging and new technologies. How to collect data of various sorts, how to analyze data. We talked about GIS as an example, geospatial analysis. How to use statistics appropriately to make inferences. Is this statistically significant? Are Friday evenings from 6 p.m. to 9 p.m. the increased rate of fatalities or major crashes significantly different than 6 p.m. to 9 p.m. on other days of the week or in a certain location? Because if you are challenged in a court of law or elsewhere, you can come up with and say, hey, this is defensible. So this is a very busy slide. You will get a table that looks somewhat like this afternoon for crash data from the state of Nevada. There are many, many, many fields. We'll explore that this afternoon. Okay. But this is just crash data. How about tying it? So this is just in Las Vegas. So many crashes in the metro area. It doesn't make sense to look at it over 5 years or 6 years, 2015. We have to drill it down to specifics. So the next slide gives you an example of one work that I'm doing with a graduate master's student, Sushma Koneti. She is looking at safety at signalized intersections where we have to make left turns, which is similar to right turns in India. And we have different signal controls. Protected left turn arrow means you can make a left turn, no other conflicts with pedestrians or with other modes. A permissive is either flashing yellow. Do you have flashing yellows here? I haven't seen in India. You do? Yeah, which means you yield to oncoming traffic or give way to pedestrians who may have conflicts with your movement. Or it's a flashing yellow, or it could be a solid green. And the question we are asking, the hypothesis is that the safety outcomes for pedestrians or other motorists is the same at signalized intersections with permissive green, which is flashing yellow or solid green, as with protected. The alternate hypothesis is that it is not the same. So to do that, we identified 119 intersections in the Las Vegas area. We have more that are signalized. And there are different cities you can see here in the Las Vegas metro area. This is Air Force Base. The yellow is the city of North Las Vegas. Pink is the city of Las Vegas. Down here is the city of Henderson. And here the rest of it is just the county. There's no city, there's no town. It is under the district administration. So we tried to pick intersections that are in all of these. And what the dots show are the fatal and A-type crashes. So the left one is just a frequency count, but if you do it as a heat map, so this is some of the GIS capabilities. Once again, if you are meeting with an elected official or a police officer, police commissioner, to say, hey, here are where the prevalence is. And we're going to go into more greater details, but just to show you visualization. They don't want to look at a spreadsheet or anything, just show us where the problems are, what are the magnitude of the problems, so that we can work to improve it. So this is an example of some communication tools that we can use. Here is another example. What we were looking at is specifically with regard to pedestrians. A lot of people use motor vehicles, usually four-wheelers in the Las Vegas Valley. Motorcycle is much lower, and bicycle is even lower, and transit usage, public transit buses account for a very small portion, 2-3% at best of daily trips. But we had more than 100 people, pedestrians, killed on the roadways in the Las Vegas metro area last year in 2024. That's a large number. In the state, we had a total of 409 fatalities, of which 109 were pedestrians in Las Vegas. That's 25% or more. Where do pedestrians interact with traffic most? Pedestrians are not going to walk long distances there. So they're walking to or from a bus stop. So the approach we are using is, for every signalized intersection that I showed you on the previous slide, we are identifying where are the bus stops. There were 4 bus stops. So the bus is going north south and east west. So that is north south, that is east west. So there are 4 bus stops that are proximate to this signalized intersection. So what we are going to do is, this one was a 500 feet buffer from the center line of the intersection. Say people will walk 500 feet to go. So if you're looking at an average walking speed of about 3 feet per second, so in 1 minute you're looking at 3 to 3.5 feet per second, 180 to 200 feet per minute. So 500 feet is 3 minutes, maybe 1000 feet is 6 minutes, 8 minutes, something in that order. So just as an illustration of the method, we have looked at these bus stops. One is a 500-foot buffer. The next thing what we are going to do is look at the farthest bus stop, and for every bus stop we have data on how many people got on the bus, how many people got off the bus, by day, by time of the day. So that's the temporal and spatial. Now these are people who are likely to be using the roads and crossing. That gives us a sense of what is the activity. We know 109 fatalities, but how many in this? So the red dots here are fatal crashes, crashes that no, these are pedestrian crashes, not fatal. The red dots indicate where we had pedestrian crashes. Now within the buffer we can see how many fatal, how many major injury crashes, tied to how many pedestrians, or how many people got on buses, got off buses. So it's just not a frequency count. We are trying to come up with a measure of exposure. Getting pedestrian exposure data is very difficult. I'm getting ahead of myself. We'll get to the metrics, I think, in day 3 of this thing, but I wanted to alert you to a method that we could use. Another tool, and this too is just very brief. This is from a company called Streetlight, and they have a software called Insight. We are able to get traffic volumes for each approach. So this is one intersection. At the intersection, how many are going through, how many turning left, how many turning right for each approach. This is very difficult to get from traditional data sources. What are they using? They are using tools such as mobile phones to figure out trajectories of vehicles. We'll see more of that later. That is also for getting measures of exposure. It's just not number of crashes. If I'm interested in crashes, pedestrian volumes interacting with turning vehicle volumes, that cross product is what is a measure of the risk. Right? So how do we get that? So that's one more of the emerging tools. We'll get into that later. Here are some questions for you to ponder about. We'll take this later. I want to move to the next. Once again, buckle up, folks. If you are in a motor vehicle, every trip from start to end, every position in the vehicle. All right, so here are some of the objectives, introduction. What are we going to do? Basically looking at data and how we can use data to help improve safety. How might we aggregate, integrate, link, centralize data? So looking at crash reports, I'm talking with the United States as a context. There is a crash reporting. We'll get into details of each crash report in the tutorial. I'll show you what data are captured in each crash report. But at a national level, there is a representative sample of crash reports. It's not every crash, but a subset from a statistically there's a sample design, experiment design to figure out what would be the appropriate number of samples based on geography, types of roads, rural, urban, so on and so forth, freeways. The CRSS then ties together data from all types of motor vehicle crashes, pedestrians, bicyclists, motorcyclists, four-wheelers, commercial vehicles and the like. And then these also serve to say for a check and balance when each state reports their crash data, how does that compare? Oh, one state is reporting 90% rural crashes and 10% urban crashes. Another state says 60-40. Does that make sense? But then we need to compare with what is the extent of rural road network, urban road network, rural population, urban population, so on and so forth. This is just to get a sense for what is it across the nation, how does that compare regionally. And then this is what is used to look at not just historical patterns, are there changes in patterns. So think about a state is okay, we had 400 crashes last year, 400 crashes, 400 fatalities, 390 fatalities, 401 fatalities, 348 fatalities, 280 fatalities. So the state is the number. So as long as it is around 400, it is somewhat stable, right? We can look at a tolerance. But what we are interested in is also a change of state. Oh, you had 400, 380, 390, 410, all of a sudden you went to 250. So that the change of state is significant, good or bad. Maybe from 400 you went to 500. It could be all crashes, it could be a particular type of crash. So what we are interested from a data analysis perspective is at a local level, at a regional level, at a national level, what are the trends? What is the magnitude of the problem? What are the changes in the magnitude of the problem? Because that could be an indicator of certain other underlying causes and how might we try to address those causes. Then we have the driver's motor vehicle records. In the United States, it's called the DMV, Department of Motor Vehicles, or some states may have minor variations to this. And there is an organization that is a collection of all these DMV offices across the country. They maintain, based upon the driver's license number, record of the driving history, how many violations, what types of violations, when and where, so on. But that's a well-guarded secret within that agency. They may use that to say, okay, you got so many demerits or penalty points, so we are going to suspend your license or give you a limited privilege. You can drive only within a certain distance, or you can drive only to your work and back. Because in the United States, if you take away the driving license, that's almost sending you to prison because you can't go anywhere. There's very little public transport options available. They also share that with the insurance companies. So that's one. The insurance companies have excellent data. Unfortunately, because of their competitive business models, they don't share that with others. And there's a national driver registry, more so for commercial drivers, truck and bus drivers. We have a separate type of license called CDL, Commercial Driver's License, which you need to have if you are to operate, if you are to be licensed to operate a heavy vehicle, like a truck, a lorry, or a bus above a certain weight class. What I've seen in India, particularly in the rural areas, is you may have a driver who may or may not have a license, and in local parlance we have a kili. A kili is a cleaner. Helps the driver and rides in the truck, so on. So those of you who speak Tamil or Malayalam can relate to that. Kili. Kili could also mean a bird. Okay. But the kili then helps the driver. He starts driving the lorry on short assignments, maybe park it, maybe, and graduates to driving. Did that person have formal education or training driving? And they probably operate the lorries on the roads without having this formal license. we need to clamp down on that significantly in India if we are to make a big difference there. So, but in the United States there is a national registry, and if there are repeat violators of these CDL privileges, that is something that is shared across the country. What is interesting is we have a criminal database that is far better of offenders who have sexual violence or sexual assault or other major bodily harm that they have caused. So these are called felonies in the US, major, and others are misdemeanor or minor violations. Okay. So there's a very good example for us to model, but why are we not doing that in the traffic safety domain? And examples include revoked licenses, saying that, oh, you got too many penalties, so we are taking away your license. You have to go through the whole process to get your license again. A suspended license means that, okay, for a certain period of time, 3 months or 6 months or a year, your license is suspended. You cannot legally operate a motor vehicle, but after that it is reinstated without any other formal process. Cancelled, okay, taken away forever. Denied is during the licensing process or renewal of license process. For whatever reason, the driver's license licensing officer inspector says you're not qualified to drive, so you're denied a license. Why can't we share this? Because if I'm denied a license in state A, I just go to the state B and say, okay, I want to get my license there. What makes me qualified to drive if I failed it in state A versus failed in state B? Unless I have significantly improved my abilities, knowledge, skills, and abilities. Why can't we share them? For the CDL, that is shared, but why can't we do this beyond the CDL? So what we are looking at is using data to inform decision making, whether it is through models, through statistical analysis, so on. And yesterday I showed you the strategic highway safety plan, example of a highway plan from Nevada. How might we use such data to drive the strategic highway safety plans? That is at the state level, but similarly at a state, local level, at a district, city, so on. And somebody online had talked about investments. Where do you want to spend money? It's just not money, it's time. Where do you want to send? We already have X number of police officers. Where do you want to deploy them? So now from the private sector, most companies that have fleets of motor vehicles, say delivery vans, trucks, they maintain very good records of their vehicle inventory, vehicle conditions, maintenance, so on and so forth, because for their business purposes, how much are they spending? Oh, this vehicle is too old, it's costing us more for maintenance. Maybe we buy a new vehicle, get rid of this. Right? Driver's records, not only the driver's licensing, but many of these companies contract with other, quote, IT, information technology, unquote, companies to monitor driving habits. And they have sensors embedded in the vehicle. So how often is driver number 1 exceeding the posted speed limit? For how many miles, for what percent of driving time, what percent of trips, so on and so forth. Because their insurance premium is based upon the risk that their drivers pose. So they want to minimize the risk, and they use that for driver re-education, retraining, to say, hey, here are issues that you seem to be in. You have a lot of hard braking. You speed, then brake, speed, then brake, speed, then brake. That is not good for a number of reasons. Fuel economy, that's big for them. Wear and tear on the braking system, so on and so forth. And that is also aggressive driving. So the private sector companies maintain these. Why can't we work with them to leverage this? They also have data on the inspection. Oh, I need to crash and roadside inspections. Did a police officer pull a vehicle over? What did the police officer find? That might be to correlate with their own maintenance people, may or may not have found that issue. or is it a certain issue that their maintenance people are consistently missing, but the law enforcement is consistently picking up? So it has a lot of things in terms of their own internal operations, and they have to report some of these too. But why can't we then work with them from a broader safety, the societal safety perspective? We have crash reports. For every crash that is reported on a public roadway in the United States, there is a police officer, law enforcement officer who investigates and writes up a report. There is a standard form. I shouldn't say standard form. It is called the MMUCC. We'll get into that later. MMUCC. Model, minimum, uniform, crash, criteria. Model, minimum, uniform, crash, criteria. Among the traffic data geeks, it's called MUCC, MMUCC, MUCC. That is a nationwide guidance that the US Department of Transportation, in consultation with stakeholders, has developed, saying that every crash report will have at a minimum all of these data elements. So there is consistency, whether it is a city police, whether it is a district police, a state police, national highway police, whatever it is, all of them will have a minimum these data. Some states or some jurisdictions may choose to add other data, but you must have these. So now we can do comparative analysis with comparable data across jurisdictions. And some of the key data include what I have listed here, and we'll get into more details of this work with the data in your tutorial starting this afternoon. You will see what are the elements there. You're not talking about 10 fields, you're not talking about 20 fields, you're not talking about 50 fields, more. Somewhere in that 50 plus, it varies. Okay. So there are fields that are what are discrete entries. There are fields that have narrative, such as a crash narrative. Others are date, time, location. There are challenges I'll show you in just a few minutes in terms of how we capture it. The legacy ways versus the newer tools. The crash report, each crash report has information about where it occurred, when it occurred, the type of roadway, roadway factors and conditions. The vehicles involved, the people involved inside the vehicles and outside, pedestrians, bicyclists and others. And the last part is a crash causation and narratives. This is where it is more like a paragraph or so that the police officer writes up. And usually there are also crash collision diagrams that sketch out the trajectories that vehicles followed, where did they collide, what type of a collision and so on. So in Nevada, the crash data are maintained by the Nevada DOT, but how do they get it? We have 47 different police agencies across the state of Nevada who have jurisdiction or the authority to write challans on the roadways. So each of these agencies sends their data to the Nevada DOT, we call it NDOT. They do the quality assurance, quality verification, tie it all together and make it available for analysis based upon a need base. It's not just they're distributed. So we have access at the university. I've requested access, my students have access, my collaborators have access, but you have to demonstrate a need for that. Even there, we don't have access to all the data. We don't have access to what are called PII, personally identifiable information. I may know that a motorist involved in a crash was 33 years of age and male. I won't know that the motorist was what the name of the motorist is, the address of the motorist. So that's considered personally identifiable. But we need that for certain other types of analysis. For example, if I'm trying to find a repeat violator, unless I know the driver's license number, I don't need to know whether it belongs to me or Nibjyoti, but I need to know our number, and with that number I can say, okay, Shashi's license Every week he has 1 or 2 speeding challans. So you can relate it, but we don't have access to that. NDOT also generates their own reports on a monthly basis. The Nevada DOT, in partnership with the Nevada Office of Traffic Safety, that's a different department than the Department of Public Safety. They publish a monthly report for each county. What are the number of crashes, types of crashes, fatalities. They don't publish the A, B, C, O. Under the CAPCO, they only are publishing K. They also publish some graphics, either bar charts or pie charts like what I showed earlier, or maps like what I showed just a few minutes ago, heat maps of where crashes. They don't show locations of individual crashes, but heat maps in terms of the concentration or lack thereof of crashes. So that, on the previous slide is the TRCC, Traffic Records Coordinating Committee is a statewide entity. The TRCC works with all of these entities and the state agencies. The TRCC meets on a quarterly basis to look at data. The whole thing is traffic records, and I'm a member of the state TRCC also, to look at historical, emerging or changing trends and what we need to do. But one of the things that the TRCC has been looking at more closely in the last few years, in the recent past, is how do we integrate the data, and how do we also automate processes to link data. So that's what the TRCC's goal is, and nationwide each state has their own TRCC, and there are conferences that are held where people come together. What did we do, what did we learn, what works, what doesn't work, best practices, so that we can adopt or adapt these. Yeah, I talked about the Nevada DOT GeoHub, where they provide maps and data. And in the Las Vegas metropolitan area, I showed you there are different cities: City of Henderson, City of North Las Vegas. They have their own police department. City of Las Vegas and the district have a joint police department. Then on the national highways and the state highways that we have, it is the state police who have jurisdiction. Then within there we have some national park or state park roads. So the state park police have the jurisdiction. Within the university, we have university police. So the university police has jurisdiction. Airport and the perimeter around the airport, you have the airport police. So they have jurisdiction. You see, right in this one area, we have 8, 9 different agencies. So the Las Vegas Metro Police are looking at their jurisdiction. How do we collect, disseminate, integrate the data there? And the graphic here on the right shows how many incidents and fatalities. You have daily reports. You can zoom into a particular area. You can zoom into a particular area in time and get some summary data and statistics. So the latest data we have available for Nevada is for the year 2023. Those of you who came in late, Nevada is a state just like Assam. That's the state where I live in, okay? And I'm based in Las Vegas, Nevada. That's the city. So the latest data we have is for 2023, but that is not complete. When I say we have, the research team that I work with at the University of Nevada, Las Vegas. For 2020, just a few weeks back, we got the K and A type, killed and serious injury data, but in the CAPCO scale, we don't have for the B, C, and O type crashes. And they do provide some geomapping. This is some information I was able to gather about India. As many of you talked about, the MORTH is the nodal agency at the central government level that has a lot of this responsibility of jurisdiction. This is a report for the year 2022 that I came across, and covers, and those of you who came late, these are not accidents, they are crashes. Very few of the crashes are accidents, okay? So data about crashes, the severities and fatalities, comparative analysis across different types of roads and across different states. And Professor Maurya yesterday showed some graphics that showed where Assam is with regard to other states. He talked about Tamil Nadu being at the top or the bottom, whichever way you want to look at it. So those are examples of at the national level data that are collected. So this is a very busy slide. I apologize for that, but it is basically to show that data are being collected, but the focus is on, again, accidents, fatalities and persons. As can be expected during the COVID year, there was a downturn reduction, but across the board it is fairly flat regardless of the metric that you look. Accidents or crashes up top, fatalities are the red lines, and persons injured are up top. And as Professor Maurya mentioned yesterday, and I believe I alluded to it too, this is at a minimum. There is a significant undercounting or underreporting of traffic safety data across India. And India accounts for about 12%, at least 12% of the total road fatalities worldwide. That's a lot, folks. Even though we don't account for that percentage of motor vehicles, registered motor vehicles or motor vehicle operations. And this comes back to the 4 E's that we have discussed. How do we have better engineering, education, enforcement and emergency medicine to minimize these adverse safety outcomes? The driver's license records, I believe I have touched upon this earlier, so I am not going to go into greater details here. In Nevada, some of the analysis we have done include driver's license by age or age groups, not necessarily a particular age, 16 to 20 years of age, 20 to 25, 25 to 40, so on, different groups, to look at comparative outcomes in terms of involvement in crashes, involvement in fatalities, A-type crashes, so on. But we don't have a perfect match of the age and the outcome in terms of crash reports. Some records have the age, some records don't have the age. But suffice it to say that the younger drivers, age-wise, have a much higher proportion of involvement in fatal crashes and serious crashes, and part of it relates to lack of experience. I will modify that by saying not just younger drivers, newer drivers. Increasingly in the last 10 years in the US, the young folks are not running to get their driver's license the first day they are eligible. Remember, I mentioned that at 16 years of age is where most of the US, on your 16th birthday, you become eligible to get a driver's permit, and then you have to have a permit for a certain amount of time before you can take your exam to get your license. Until about 10 years ago, most children on their 16th birthday tell their parents, I need to go get my permit, I need to get this. But what we have seen is a dramatic reduction in people getting their licenses at an early age. Some are waiting until 20, 22, 23, so on. Same thing, vehicle ownership. It used to be that people started buying cars, each person saves up. It's not mommy or daddy or grandpa or grandma buying a car for you or a motorcycle. You save money, you buy your car, okay? Nobody is giving it to you. So they save money by working. They start working even when they're in high school, get money, buy cars. And the ownership, the first ownership of cars was somewhere in the late teens. But over the last 10 years, what we are seeing is that too is delayed by 8 to 10 years of age. I'm going to break you up into groups of 2 or 3 where you're sitting. If you're sitting in a row of 4, you have to be 2 people to a team. And here's a question, and you have 60 seconds, 1 minute to come up with an answer, and I can call on anybody. So there are several people who came new. You don't know my process. The question is, why is it that over the last 10 years, the young people are delaying getting their driver's license in the United States? Why are young people not getting their driver's license as early as they are eligible to? Why is there a delay? You got 60 seconds to go starting now. Same thing online. Ritvik, I saw your message pop up. Hold on to that. I think you're answering a different question. Five seconds. Okay, time. Would you raise your hands? If don't answer. If you have an answer, raise your hands. I'm going to call on the new folks, the people in the last row, far right. What did your team come up with? I just want one reason. I don't want an essay. Identify yourself so that I know who you are as well as people online. State your name.
Sir, my name is Akshay.
And your teammate is?
Mega.
Okay. Akshay and Mega, what did your team come up with? Sir?
Sir, the licensing procedure may be difficult.
Licensing procedure may be difficult. Okay. The next team, identify yourselves and what is your answer?
My name is Arshita Dhakkar.
Please use a microphone. People online need to hear you.
Sir, my name is Arshita Dhakkar and my partner's name is Nishat Tasneem. So,
Quick.
Sir, because of the safety purpose, like,
Safety purpose, they are afraid and not getting license?
yeah.
Okay, all right. Online, may I have a show of hands who wants to speak up? I see Verma, before Verma, somebody else. Who's number one? Singh, SS, yeah.
Hello.
Yep,
Yes, sir. Maybe it's due to the betterment of public transportation, like Gen Zs, they are preferring that more.
okay, better access to,
Environmentally aware, they're getting
okay, I want a
environmentally
short
aware, so
answer.
they are-
Short answer, better access
Sorry.
to public
Sorry.
transit, okay? Verma?
I think to better understand the road safety concerns, because young people can have a thrill. So might be if they have like observing road safety and all things later, like they can behave very well on the roads.
Okay, so
So
they
might
want
be
to
they-
just spend more time observing, okay? Tazim?
Yes, sir. I think the young generations are quite of some temporal-minded. That's why the government might have hesitant to give their license.
Oh, difficulty in getting a license from the government, okay. Who in this room? Yes,
Sir, affordability.
hang on. Ritesh?
Yes, sir. Might be in the early days they are not a good in driving. They don't want to make more violations and get the license revoked or suspended.
But how do they know they are not good if they don't have a
They
license?
can like train on the simulators and all.
Oh, wow.
Right now,
Okay.
driving schools are there. They are
High-tech
firstly
simulators.
training on the simulator.
Okay. Who was it online who wanted to speak up? Was it Ashutosh?
Yes, sir. Because the fatality rate for the young peoples are more in Nevada. That's why.
So they are waiting to get their license, okay. Anybody else here?
Yes, sir.
Yes. Please identify yourself too. Vineet? There are plenty of mics.
Yeah, myself Vineet and my teammates are Preetham and Rahul. And they might have developed good skills in driving, but lacking in knowledge of traffic rules.
Okay, so I hear an assortment of reasons. Many are plausible. Did you have a comment? Okay. I don't know the exact reason. There are social behavioral scientists who are looking at it, but affordability may be one angle. Okay. Now, I'm going to pose another question, 30 seconds for you to work with your teams. Why are the young people waiting to buy cars? They are not buying cars as early as before. So you have 30 seconds to come up with it. Okay, 5 seconds. All right, somebody who has not spoken up in the room.
Sir, inflation.
Who was that? Oh,
Yes, sir.
inflation. Yeah, good. Inflation, so cost. Yes, Ishita, please identify yourself so others online can also.
I'm Ishita Pragya. So the affordability is one of the reason, and the
One reason,
uh,
affordability,
and the insurance cost is high.
insurance costs. Okay, anybody else in the room here? Online? Ashwini?
Renting a car is very, very easy.
Renting a car is easy. Okay, anybody else online? Okay, so I think affordability, I take cost of insurance into that affordability. How much does it cost? That is one. The premiums, insurance premiums for young people are very high in the United States because they have a much higher risk of being involved in a crash. Is there anybody here who has been in an Uber in the last year? Is there anybody who's not been in a Uber in the last year? More than 10 years ago, we didn't have the Uber culture, right? So now, with your mobile phone, you can call a ride. So overall, that compared to what Ishita said, two parts. One is the cost of owning and operating a vehicle versus the cost of getting rides through a Uber or Ola or whatever be there. It's, people do the calculation, it is less expensive, maybe more convenient. In many urban places, parking is a problem. I know in India too, that's a problem. Whereas if you get a ride, you just get picked up and you get dropped off. You don't have to worry about finding a parking spot. So these are some of the examples. But so the challenge then is not just with the young drivers. The new drivers have a much higher risk profile in terms of adverse safety outcomes. So if somebody got a driver's license at the age 22 compared to another individual who got a driver's license at age 16, for the first 2 years or 3 years, they have, provided they are driving about the same amount, their learning curve is going to be the same, except the person who's 22 is probably a little more mature than a 16-year-old. Let me move on. So Challan, there is a legal definition, types of violations that are captured, and the big problems here and across the world, in the US, are issues related to privacy. I mentioned that earlier, PII, personally identifiable information. But there are other ways we can do analysis of data without going into PII. That will be a little more macroscopic without knowing who the individual is. But to get corrective action, behavioral changes, to some extent, we need to have that PII, or who are the repeat violators. We talked about that in the previous lecture. And many organizations have lots and lots of data sharing policies that preclude sharing beyond. And of late, there are issues related to cybersecurity. If you have data on a server or on a portal that you make available to people, what if you have an intruder who hacks into the system and accesses it? Not only accesses the data, but then hacks into the rest of your data set, the rest of your records. So here we are looking at identifying high-risk zones. Now, not looking at individuals. Where are you getting a lot of challans for a certain type of violation? How effective are you with your police, either in a zone or at a certain time of the day, day of the week? Tracking habitual offenders, it comes back to being able to get information about individuals. So that's a little more challenging unless they keep coming to court, they are forced to come to court, then you know that. Not just Delhi, we put in Delhi, but many areas here in India now have automated challans. I was just talking to somebody who parked outside a bank for 2 minutes, went in, parked and came back, and within a few moments he had a SMS with a photo of his car saying parked in a no parking zone. And in this case it happened to be there was somebody who was walking and monitoring the no walk, but you have enforcement cameras, either it is for parking or speeding or violating traffic signals and so on, not yielding to pedestrians. So there's a lot of automated enforcement. Unfortunately, in the state of Nevada where I live, the state law says that we cannot use automated enforcement to issue challans. We cannot use. So there has to be a police officer who observes a violation to be able to write a challan. And in one of my other activities, we are working with the state elected officials to at least rescind that law. Stay silent, don't say whether you can or you cannot use. Or another thing, allow us to use automated enforcement in a few high risk locations in selected areas, in school zones, in construction zones. We'll show you how effective it is. But once again, their concern is privacy. Oh, you're going to be intruding into the privacy of individuals. And my response to that, my personal response to all of you and others, is that if you don't violate the law, you don't have to be afraid of your intrusion of your privacy. We take your photo only if you violate the law. Stay within the bounds of the law, you have nothing to worry about. But that doesn't quite pass muster with the elected officials. So the legacy approaches have been paper based, manual entry, errors in terms of reading people's handwriting, how they enter it, what they say. It's very labor intensive. In India that might not be an issue, cost of labor is relatively low compared to the US. There are interperson and interagency variations. The same incident could be reported differently by different people. There's a delay. You write it on a sheet of paper, by the end of the day you go to your police station, you submit it, then next day somebody else figures out whether to scan it, enter it, so on. So this days, weeks and so on. Then it goes to a central command center, from there it goes to the, so there are lots and lots of delays in just getting this to a place where it can be tied together, and then if I wanted to access it, you wanted to access it, it is subsequent delays. So there's a time gap between when the violation occurred versus when it. In Nevada, I told you the most recent data I have is 2023. That is still old. We are working to try to get it. These officers, at least at the end of the day, we have electronic things, we'll get to it. We can upload it within 24 hours. So maybe a lag of a day, 2 days and so on. For some analysis, it doesn't matter whether it is a day old or 2 days old or even 2 months old when you're looking at long historical trends. But there are other types that where we need much shorter time. And there is poor integration with digital systems. In India, what I've observed is that there's a lack of actual data that is recorded. There's quite a bit of anecdotal data, especially when you move away from urbanized areas. You go talk to a village chief or villagers or a shopkeeper along a road. They will tell you, okay, last year on June such and such, they may not know the date, there was a crash, there's a motorcyclist, he was turning into a truck's path. It may not have been recorded because there may not have been a major, but they can tell you, oh, this location every day, every week we can see people screeching, braking, so on. So how do we, but then there are inconsistencies or variations. What you observed and how you narrate it may be different from how you narrate it, the same thing. So that's a challenge in India. So digitization, whether it is challan citations, helps expedite this, bring about consistencies. As I mentioned earlier, you have a lot of drop down menus or discrete fields where you can pre-code and the officer just has to click. So there's much better consistency and much less variability across individuals who are putting this together. It also makes it easier to add it, integrate it with spatial processing tools such as GIS and now leverage artificial intelligence. I'll show you in a slide some of the machine learning, natural language processing type tools and techniques. IRAD will talk more about it. I think Professor Maurya is going to talk more. He mentioned it yesterday. And in Nevada, we have had over the last 15 years more and more 96, I think there's 1 out of the 47 agencies in Nevada that does not use the electronic challan preparation. Some of the emerging tools and approaches, we'll get into much greater details in this later, but I just wanted to give you a feel for it. Looking at the way we call it is from data to discovery. You translate data to information, to knowledge, to decision, and along the way you discover, uncover, reveal issues, problems, needs, challenges, and opportunities. So some examples include, one of the things that I'm working with another colleague is crash narrative analysis, unstructured text. One field in the challans is a paragraph or narrative section that the police officers write. I don't have the domain expertise in machine language, natural language programming and processing, but he has that. But I have expertise in the traffic safety. We're collaborating. So he's looking at not one word, not 2 words, but strings of words that the police officers write in their challans to say, okay, what are the underlying causes, root causes? Whether we look at a string of 3 words, 4 words, 5 words, and how many words do we need to look at concurrently, consecutive words, before we lose the efficiencies. The other thing we are working on is, instead of the police officer using a tablet or a computer and marking, speak. So voice recognition. That will speed up, reduce the time it takes to document this. So these are some of the evolving approaches or methods. And looking at predictive analytics is looking at historical information, and what you see now, AI. What is AI doing? Looking at gobs and gobs and gobs of data and try to extract patterns. It's not necessarily a causal factor, it's more of a correlative analysis. We may be then able to use that to get to causal analysis. So there are lots of benefits to centralizing or aggregating. We'll get into more details of these when we go into the next phase, where we look at emerging tools and techniques. And IRAD, Professor Maurya is going to talk about that. And I mentioned the model minimum uniform crash criteria as we work on the tutorials. We'll get into a little more of that. The UK has their own system, Australia has their data, and lessons for India is the need to standardize. I believe that's where the IRAD is going. And so here are some of the challenges that I've touched upon in terms of looking at the old systems, very labor intensive, time delays, inconsistencies, inaccuracies. But when you stitch them together, there are issues related to security, privacy, that a lot of people are concerned about. We have to find a middle ground between these. What is in a public interest versus what is an individual's interest, and what is the middle ground between these. Future directions, once again, this is just to give you a feel for some of the things that we'll discuss on day 3 and day 4. Some I'm involved with, most I'm not involved with. This is food for thought for you all as you're looking for opportunities, challenges, either in your academic careers, or maybe you want to start a business, entrepreneurship, to say, hey, I want to start a company that will do this for you. So to summarize, there are tremendous advantages, value to leveraging traditional data. Even though it may not be digitized, try and see if you can get access to it. How do you leverage that? If you can get to electronic records, the newer emerging tools and techniques, that's something that will add, make it more effective, more expedient, more efficient. How do we aggregate data? We talked about crashes, citations, driver's licenses, motor vehicle registration, so on and so forth, insurance data. I don't have answers, but these are opportunities. There are some examples that I will share with you, but that's not the solution. That is a solution I'll skip this. We are right at beyond time, 5 minutes past where I told you I'll finish. Any questions or comments? As I said, everybody, every trip when you are in a motor vehicle that has a seat belt on before the engine starts, stays on until the engine stopped. Everybody, every position, every trip. Yes, please speak up.
Sir, how can we find out property damage only crashes?
In Nevada, it is in the crash report. They say, and if there's anybody injured, it is recorded. You'll see that in the data set that I will share with you this afternoon.
Just I am asking, sir, while collecting data, how can we say that this is PDO crashes?
Okay, so the question is, how do you differentiate PDO crashes? You or I are not making the decision. It is the police officer at the site who is making the decision. If the police officer says there is an injury, there is a field. Was there an injury? Yes, tick mark. How many people were injured? 1, 2, 3, 4, 5. What was the extent of injury? Killed, A type, B type, C type. So it is recorded in the crash report. It is not those of us who are accessing the data who are making a decision whether it was K, A, B, C, D or property damage. Any others? Okay.